We are very excited to have begun testing the first two F-130 engines for the United States Air Force's B-52 fleet.
Rolls-Royce, a brand synonymous with engineering excellence, has recently announced a groundbreaking upgrade to its F-130 twin engine, marking a pivotal moment in both military and aviation history. This comes after the U.S. Air Force's B-52 Stratofortress, a long-range subsonic strategic bomber that has been in service for an astonishing 70 years. Initially powered by 4 pairs of Pratt & Whitney J57P1W turbojets that were ingeniously placed under the wing on the leading edge. These original engines, each generating 10,000 pounds of thrust, were once even employing a 1,400-litre water injection system to temporarily boost thrust to 11,000 pounds. However, as the fully fueled weight of the B-52 was estimated to exceed 500,000 pounds, the need for a more efficient and powerful engine became increasingly evident. The F-130 is not just an incremental improvement. It's a leap forward in engine technology that promises to redefine aircraft performance parameters. With higher thrust, better fuel efficiency, and lower emissions, the F-130 aligns with global sustainability goals, setting new standards for the future of aviation. In the 20th century, Pratt & Whitney's engines were the gold standard in aviation, equipping a range of aircraft from jetliners to bombers and fighters. The B-52 Stratofortress, a mainstay of the U.S. Air Force for over 70 years, initially flew with Pratt & Whitney J57P4WBS engines, each generating between 10,500 to 13,750 pounds of thrust. In 1961, the most significant engine upgrade until that point came in the form of Pratt & Whitney's TF33P3 turbofans. Each of these engines produced an impressive 17,100 pounds of thrust, a substantial increase from the original J57P1W turbojets. This upgrade was a game changer at the time, enhancing the B-52's performance metrics. The TF33P3 engines allowed the B-52 to carry more substantial payloads and operate at greater distances, aligning with the evolving strategic needs of the U.S. military during the Cold War era. According to the U.S. Air Force, each TF-33 required an overhaul every 6,000 flight hours at a cost of $2 million per engine as of 2019. These financial and operational burdens, coupled with a staggering $70,000 per hour flight cost, made the B-52 one of the most expensive aircraft for the U.S. Air Force to operate. By the late 1990s, the U.S. Air Force was keenly aware that another engine upgrade was overdue. Technologies had advanced, and newer, more efficient engines were available on the market. However, after conducting feasibility studies and cost analyses, the U.S. Air Force concluded that upgrading to new engines would be prohibitively expensive. This decision was a pivotal moment, as it meant that the B-52 would continue to operate with increasingly outdated technology, leading to higher operational costs and reduced efficiency. The financial constraints overshadowed the long-term benefits of an upgrade, causing a delay that would last for over 2 decades. By April 2020, the need for an upgrade was undeniable. The U.S. Air Force released a request proposals for 608 new commercial engines, finally acknowledging that the older Pratt & Whitney models were no longer sustainable. When the U.S. Air Force issued its proposals, it opened the floodgates for fierce competition among leading aerospace manufacturers. General Electric, a stalwart in the industry, proposed their CF3410 and Passport turbofan engines as were the successors to the aging Pratt & Whitney models. Not to be outdone, Pratt & Whitney themselves threw their hat into the ring with their advanced PW800 models. However, it was Rolls-Royce and their F-130 engines that ultimately won the U.S. Air Force's favor, securing a $2.6 billion contract for a total of 650 engines. Of these, 608 would immediately replace the existing engines on the B-52 bombers, while the remaining 42 would be kept as spares. Rolls-Royce's F-130 engines, promising not just increased thrust, but also upgrading the Stratofortress total thrust from 136,000 to 172,000 pounds, but also greater fuel efficiency and reduced carbon footprint. This monumental shift is not merely a change of supplier. It's a comprehensive overhaul aimed at modernizing the B-52 fleet to meet the evolving strategic needs of the US military while aligning with global sustainability goals, and it is clearly visible with US Air Force's proposals. The decision to go with Rolls-Royce was not made lightly. The F-130 engines come from Rolls-Royce's BR family of engines, which have amassed over 30 million hours in operation, making them a paragon of reliability, dependability, and fuel efficiency. These attributes were crucial in the US Air Force's decision-making process, especially given the lessons learned from the late 90s when they considered but ultimately rejected an engine upgrade due to cost concerns. This time around, both the US Air Force and Rolls-Royce agreed not to alter the engine design, even though a 4-engine configuration could potentially make the Stratofortress more efficient. The reason for this was practical. Retrofitting the entire fleet to accommodate a different engine configuration would not only complicate the upgrade process, but also inflate costs. Rolls-Royce has announced that the testing of these game-changing F-130 engines will take place at NASA's Stennis Space Center in Mississippi. The choice of this location is significant for several reasons. First, the Stennis Space Center is a hub of aerospace innovation, providing advanced testing facilities. Second, conducting the tests at a NASA facility adds an extra layer of credibility and severity, ensuring that the engines meet the highest standards of quality and performance. Finally, the engines will be manufactured, assembled and tested at Rolls-Royce's largest manufacturing facility in the United States, located in Indianapolis. This decision not only creates American jobs, but also streamlines the logistical process, given that the engines are destined for the US Air Force's B-52 fleet. This collaboration comes after Rolls-Royce's substantial investment of over $1 billion in the modernization of its Indiana manufacturing and testing facilities, as well as in cutting-edge technology. The US Air Force's decision to work closely with Boeing, the original manufacturer of the B-52, underscores the critical nature of this upgrade. Boeing's deep understanding of the aircraft's design and operational requirements makes them an invaluable asset in ensuring that the new F-130 engines are not just compatible, but also optimized for the B-52's unique specifications. The F-130 engines, which have been in production since the late 90s, were developed in a joint partnership between BMW and Rolls-Royce. This collaboration combined BMW's expertise in precision engineering with Rolls-Royce's extensive experience in aerospace technology. The engines initially found applications in various commercial aircraft, including the Bombardier Global Express, the Gulfstream 5, and the Boeing 717 under the name BR-700. These engines have proven their mettle over decades of service, making them a reliable and mature choice for the B-52 upgrade. The US Air Force has high stakes in this upgrade, as the introduction of the F-130 engines is expected to extend the operational life of the B-52 fleet by an additional 30 years. This is a monumental feat, considering that the aircraft has already been in service for over 70 years. According to Mike Seltman, the aerodynamics engineer at Boeing, the focus of the wind tunnel testing will be on the engine's digital control system and the crosswind aerodynamic flow. Boeing has even constructed a 4% scale model of the Stratofortress for wind tunnel tests at a Mach speed of 0.92 to gather essential data. This meticulous approach aims to mitigate any risks and ensure a smooth transition to the new engines. The term game changer is often overused, but in the case of the F-130 engines it seems appropriate. One of the most compelling features of the F-130 engines is their ability to increase the B-52's operational range. This is a critical advantage in modern warfare, where global reach is often crucial for mission success. The engines are also designed to be highly fuel efficient, a feature that has both economic and strategic implications. Fuel is one of the most significant operational costs for any air force, and increased fuel efficiency translates to extended mission capabilities. The F-130's impact is not limited to military aviation. Its innovations could spill over into commercial aviation, potentially revolutionizing the entire aviation industry. The engines are designed to minimize the emission of nitrogen oxides, a significant contributor to air pollution. This makes the F-130 not just an advanced piece of military hardware, but also a step forward in sustainable engineering and a greener future.